Today we're working on 11.4, circumference and arc length. We're going to start with some vocabulary. The circumference of a circle is the distance around the circle. So if we look at our circle here, we're going to look at the black dotted line, and that is going to represent our circumference. And an arc length is the portion of the circumference of a circle. And we look down here at the bottom, we see our circle with a little bit of the circumference taken out, and that represents an arc length. And let's look at theorem 11.8, the circumference of a circle. The circumference, which will be represented by capital C, of a circle is 2 pi r, or circumference is equal to pi d, and that's little d, where d is the diameter and r is the radius of the circle. Both of these formulas can be used to represent the circumference, and which one you use depends on the information you're given in your problem. Okay, first example, find the radius of a circle with circumference 26 meters. And it's important to always look at our label, because we're going to need to make sure that we continue down and label our answer at the end. And remember, the circumference is the entire distance around the circle. So we need to use our formula, and the one we're going to use here is circumference is equal to 2 pi r. And the reason we're going to use 2 pi r is because we're trying to find the radius. And now we can look back at the problem, and we're given 26 meters for the circumference, and we just set that equal to 2 pi r, and we divide by 2 pi on each side. And it's important to note here that when you use pi, you can either use pi as the character in your calculator, or you can use 3.14, but you just need to remember that your answer might be a little bit different depending on the rounding. And after we divide by 2 pi on each side, we get 4.14 is equal to the radius. And we are not done. Remember, at the very beginning I said we need to make sure we look at our label. We need to look at what we're using here. And in this case we're using meters, so our radius is going to be 4.14 meters. And this is just regular meters because we're dealing with the radius. This is not the area or a volume, so it's just normal meters. Moving on to example 2, we're looking at tire revolutions. The dimensions of a car tire are shown at the right. To the nearest foot, how far does a tire travel when it makes 15 revolutions? To solve this problem, I'm going to look at the tire. And what I see here are 3 different measurements, and this is going to give us the entire diameter of our tire. So what I want to do is I want to take all of these measurements and I want to add those together. And after we add those together, we should get 26 inches, and that is going to be our diameter. So now that we have our diameter, we can use the circumference formula to find what our circumference will be. And in this case, I'm going to use circumference is equal to 26 pi. Because remember, we have 2 different formulas for our circumference, 2 pi r or pi d. And in this case, I'm going to use diameter since we're given the diameter. You could use 2 pi r if you divided 26 by 2 to get 13, but really we're just skipping a step by using the diameter. And now we need to find our circumference. So after we multiply 26 times pi, we should get 81.68. And remember, this should be close to what you get. It just depends on what you use for pi and your rounding. And since we're doing 15 revolutions, we need to take our circumference and multiply that by 15. And after you plug that into your calculator, you should get 1,225.22 inches. Now we need to go back to the problem and see what it's asking for. And it's asking for the nearest foot. What we have now are inches. In order to find feet, we need to take our 1,225.22 and we need to divide that by 12, because there are 12 inches in a foot, and this should give us 102.1 feet. Remember, 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 always put your labels. Always, always make sure there's a label on your answer. All right, moving on to the arc length corollary. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. That is quite a long sentence, so let's break it down here into a formula. So what we have the arc length of AB is equal to the measure of AB divided by 360 degrees, all multiplied by 2 pi r. And we can use this to find the arc length of AB. Let's try an example. Example 1. Find the length of each red arc. And we're given one red arc here, and that's AB. We're trying to find the arc length of AB, and we need to plug in some information. We have our measure of AB, which is our central angle, so that's going to be 60 degrees, and put that over 360 degrees. And we have our radius, so we need to multiply that by 2 pi, and then our radius, which is 8. And you should recognize 2 pi r here, 2 pi r. This is the formula for the circumference. So we're taking the central angle divided by 360 degrees and multiplying that by our circumference. Now we simplify this and you plug this into your calculator. You should get 8.38 centimeters. Remember, we're finding this arc length out here, AB, so this is going to be a measurement, so that is centimeters, 8.38 centimeters. And we have another example here. I will give you time to pause the video now and try this on your own. Okay, let's go over this one. We have the measurement of GH is what we're trying to find. So the arc length of GH is equal to our central angle, which is 120 degrees, over 360, multiplied by the circumference formula, which is 2 pi r, and our r here, our radius, is 11. And after we simplify all of this out, we should get 23.04 centimeters. Labels are very important. Do not forget your labels on your answers. Alright, moving on to example 3. Find the circumference C of our circle with center Z. This time we're trying to find the circumference in our formula. And if I write down the formula, we have equals, and then we have some central angle over 360, and that would be our 40. Okay, so there's one piece of information we have. And we're going to multiply that by our circumference. Normally we would put in 2 pi r for this, but we're just trying to find the circumference. So you could put in 2 pi r, find the radius, and then plug it back in to find the circumference. But instead, we're going to skip a step and just say, this is our circumference. So we won't need to plug anything back in. And we're given one other piece of information, which is the arc length of XY. So that will come over here, and 4.19 will be set equal to 40 over 360 multiplied by the circumference. And if we simplify 40 over 360, we should get 1/9 times C, and bring down our 4.19. Multiply each side by 9. And when we multiply, we should get circumference is equal to 37.71 inches. Remember, this is a measurement, so this should be in inches. And that'll give us a circumference of our circle. Example 4. Find arc lengths to find measures. So we need to find the measure of our arc length, RS. And I will give you a second here for the video. I want you to pause it and try to set this equation up. Okay, you should have had time to pause the video and set up the equation. And I'm going to set it up in 2 different ways, and each way will be correct. The first way I'm going to set it up, and this is how my brain works, so you might be different, so pause on this and we will get to the second one. We have our arc length, which is 44. I'm going to set that equal to what we're trying to find, which would be our measure of our arc length RS, which is our central angle. So I'm going to say that is X. I'm going to put that over 360 multiplied by the circumference. So we're given a radius, so we need to do 2 pi times our radius, which is 15.28. And this is one way to set it up. And there's another way. So if we want to set it up a different way, we could have 44 over 2 pi times 15.28 and set that equal to X, which is the measure of our arc length RS, all over 360. And just a quick little quiz here. The difference between these two, can you see it? All we did was divide by our circumference. So our 2 pi r, all we did was divide it over and make it a little bit simpler. Now that we have both of these set up, I'm going to use the bottom to solve this. And the way I would do this, I would multiply by 360 on each side. So if I multiply by 360 times 44 over 2 pi times 15.28. Set that equal to X, which is the measure of our RS. And simplifying that all out, we should get 165 degrees is equal to our measure RS. And that will complete the video.